One of the items that we wanted to investigate the behavior of in space, which we anticipated might be slightly different at least than in one gravity field, was a paddle ball, a rubber ball suspended from a piece of elastic with a wooden paddle. And of course, in one gravity, here on the surface of the Earth, there's a certain technique that must be mastered in a way of timing, hand-eye coordination in order to make this work. For instance, of course, if I let go of the paddle ball, it's going to drop to the ground. If I pull it apart and let go, the ball may smack the paddle once and immediately drop down, but in fact, as you can see, what happens is it actually misses the paddle. We might compare this to what you think might happen in 0G. Will it still miss the paddle? We'll see a little bit later on. So we'll try that once more here with letting go of the ball. Sure enough, it misses the paddle again. How about a vertical orientation? Will it hit the paddle this time? It may depend on how far I stretch it and whether I let it go straight up or not. One hit, but then a dangling around. We can suspend the paddle from the ball, of course, in various manners, investigating the dynamics of that sort of thing. Or the ball from the paddle and investigate the dynamics of that, which we just looked at. We could, of course, let them both go in one gravity, and of course, as you just saw earlier, they would fall to the ground no matter how far I stretch them apart. So there's no point in doing that here. What we should interest ourselves in is, though, a vertical orientation, perhaps a horizontal orientation, and the normal paddle ball toward the deck kind of orientation. So if I operate the paddle ball in this sort of direction, in this sort of manner, which is kind of a 1G operation, I should be able to do the same thing in 0G. Operating it this way, however, is a little bit tougher task in the gravity field, because not only is the ball being pulled down by the elastic strap, but it's also going to fall down due to its weight and the force of gravity. So let's try that. Much harder to do. One more time. Still much harder to do. A horizontal orientation, you might suspect, depends upon the force of the elastic cord pulling the ball back toward the paddle in this kind of direction. Compare this sort of information to what we see in zero gravity with the paddle ball. The paddle ball in zero gravity is probably going to behave somewhat differently, in that I don't have to pull it back with nearly the force that I have to pull it back and smack it rather hard like I do in a one gravity field to make sure I get enough extension of the elastic in order for it to pull it back against the paddle and pull it back so that it hits the paddle instead of pulling back and dropping below it like it does in one gravity. We should attempt to pull it apart and let go to see what happens, and during a paddling exercise perhaps let go of the paddle to see what kind of dynamics that the system is going to experience in the absence of gravity in orbit.